Welcome. I'd like to thank you for joining me today as we're going to jump into serverless computing for Java. So I've been doing this for a number of years now, and I'm excited at what the world of serverless can bring to us, the humble Java developers. So excited to share this with you all. I'd like to thank Kenneth Vogel for setting up the J conference and arranging everything. He's done a fantastic job. And my right-hand man, Ryan Birch, who will be moderating the session today. So excited, but that will get to see him later on. So with that, let's get started. So the problem with Java, it's not all the code, but it's all the fluff we have to manage before our code is executed. What if we could get rid of some of that fluff? So what do I mean by that? So let's dream for a minute. If you look at what a servlet is, a servlet in its very nature, a very small piece of code, I mean, it's simple, it's easy, it's a single method, a couple of helper functions that come in, but all the container stuff around it to get it deployed, that can be quite intimidating. Let's think about processing off a JMS queue, Java messaging. Same thing. The actual messaging queue itself, I mean, that's relatively straightforward, but again, all the auxiliary fluff around it, there's a lot to go on there. And of course, we've seen so many different implementations for this little one. We've all got code in our enterprise that needs to run at a given time, whether it's some database cleanup, some queries that need to be run, directories needing to be cleaned out, something needs to be done on a pulled schedule. Think of all the different ways we've manifested that, whether it's like a Bastion host that's running a cron job that spins up a JVM to go and write out some code, or it's deep inside an application server that's running up. Again, we're all trying to figure out this timer stuff. It shouldn't be this complicated. And it really isn't. So what I'm going to do today, I'm going to go through effectively serverless and what it means to us, the Java developer. Now, I'm only going to touch upon this because this is a big area. I mean, I've only got an hour. I can only do so much. But hopefully this will give you enough to get you excited, get you started, and get you playing. Because once you get into this world, you'll discover that it's not as complicated as it seems. And the barrier to entry is woefully low. Woefully low. Now, in full disclosure, I'm going to be using AWS as my sample stuff here for serverless. Microsoft, Google, and there's other serverless frameworks out there as well. They all follow similar principles. Maybe the language is different, maybe the terminology is different, but they all cover the same sort of concepts. So serverless, let's talk about what it means. Let's address the elephant in the room straight out the gate. It's not serverless. You know, kind of like what cloud computing is. Cloud computing is really somebody else's hardware, right? Of course there's a server. There's got to be a server that actually executes this code. So calling it serverless is probably a little bit disingenuous. What we really mean is it's free of any underlying server management, right? We don't need to worry about what OS it's running, what security patches are on it. As far as we're concerned, we forget about all that. It's purely just the code that we're running. So instead of thinking of it as serverless, think of it as function as a service. So just like we've got IIS, infrastructure as a service, servers as a service, we're now going right down to that small granularity of a single function. And it literally is a single function. And it doesn't mean that all the code has to be shoehorned into that little function. We'll go through that later. But it allows us to get back at the job at hand and not be worried about the overall logistics of the server, the initialization of security, scalability, configuration, and all that sort of stuff. We get down to servicing what needs to be serviced. So when we think about function as a service or serverless, we're deploying functions. We're not deploying apps, or we're not deploying servers. We're deploying what needs to be done. And effectively, you're deploying a piece of code that's going to run off of a given event. Scalability. In this world, we don't have to worry about how many servers we're provisioning to think about a load that's coming. That will automatically be scaled up and down accordingly. So your function will run in parallel if indeed the container has decided that it does need to do that. So if there's an influx of events, then it'll start doing that. Now, of course, we can put thresholds onto that to make sure we're not landed with a huge bill at the end of the day. We're charged every time the function is called. Now, when you first tell somebody that, they suddenly go into panic mode, thinking, oh my God, I'm going to get a huge bill here. We'll see soon that the numbers are really small. So don't be thinking it's going to be like $1 per charge for every time you run a request. And here's the other exciting one that really gets us excited, and it has shown out in a number of engagements that we've been with. When nobody is calling your code, it doesn't cost a single thing. The meter is not running. Now think about that compared to historical sort of an app server that you would have spun up. You know, if that WebSphere or that JBoss instance is sitting there running, you're getting charged for that. If nobody ever touches it or nothing ever runs, you're getting charged for that server that's running. In serverless, you don't. It's basically zero cost at rest. Now, when it comes to release cycles, okay, this is a very exciting one again. You're not deploying your enterprise as a whole anymore. You're probably not anyway. You're probably more in a microservices architecture anyway. But in this particular environment, you can get even lower than that. And you're only deploying functions at a time. So you're not needing to disrupt something just because you've done a code build, right? The other cool thing is it literally is zero downtime, right? So if you're updating a function that's running in production, any function that's currently running will exit accordingly as per its normal runtime. The next time that that function is called, it will now run your new code. So you have literally zero downtime when you're releasing new code. So anything that was running in the old code will get time to finish. Anything that's in the new code will come through there. And of course, now that we're talking of a smaller granularity, because we're only dealing in functions, it should be much easier to test. It should be much easier to have a greater confidence that the testing that you're doing on that small function, because again, you're not trying to eat the elephant in one mouthful. You're eating it in small chunks. So now we can complete this testing in a much greater granularity and have far greater confidence that our testing is going to work better. So how does this work? Really very simple, and we'll show this later on. You basically, in the Java world, not dissimilar to a servlet, it's actually a lot easier than a servlet. You implement a method in an interface. That's simple. You get a couple of helper classes that come in to help you contextualize what it's doing. Again, we'll show that in a moment. Then we package up the function. And again, kind of like creating a WAR file, we're going to compile it. We're going to compile it into a single exploded jar file. Okay, so that means that this jar file doesn't have other jar files associated with it. It's going to package into a single jar file. And we'll have some configuration parameters in there to be able to tell the serverless container effectively what we want to, like for example, memory, logging, security considerations, like in AWS, which VPC do I want to be in? Which resources am I going to be running within? What IAM am I going to be working within? But again, those are advanced techniques that you'll evolve to in yourself. And then finally, we effectively upload it to the cloud. We package it, it goes to S3 in the Amazon world, and then it's sitting there ready for the serverless container to wait for an event to come along, which it'll be then unpacked and then run and execute it as per the event. So now that we've gone through the sort of serverless as a whole, let's look at what we mean by a function and what does it actually look like. Before we go into that world, a small disclaimer, AWS Lambda is not the same as Java Lambda. Two different worlds. And again, we've been around this world in the Java world before. Some of the more seasoned developers amongst us, we've had the JavaScript debacle a long time ago where, you know, aren't they the same? No. The only reason I bring it up is be careful when you're Googling your questions for serverless. Make sure you always put in AWS Lambda, so you're kept inside of that search set as opposed to the Java Lambda set, which is a whole different world. So functional programming, what we really mean by that is it's event-based programming. Okay, so that means that something happens in the real world, and we're now going to run code on behalf of that, in response of that. Sorry. So that could be an HTTP request that comes in as part of an API call, for example. And we'll see other examples of that later on. And as part of your code to do that, you decide how much memory am I going to allow this function to hold. right? And that's effectively the maximum amount of memory that's going to be allocated to your function to be able to execute that. Now, again, this is something whereby it's a trial and error thing. The amount of memory that you need is not the same amount of memory that you would have needed if you're running inside an app server. It's a completely different way of looking at it, and you'll find that you'll need a lot less memory than you thought you needed. So again, memory is tied to cost. The cost you want to keep as low as possible. Now, a function is a short-lived thing. Okay, it doesn't run forever, right? So once your function has executed, that's it, finished, no more billing. However, your function gets caught in a loop or is doing something a little bit more intensive than it should be, you're going to get terminated. And you actually get terminated. There's no exceptions thrown. There's no indication. Boom, you're out. It's gone. You have no indication that it died except for looking at it in the log files. And replying to a event coming from the API gateway, which would be your typical way of receiving an HTTP request coming in, would be only 30 seconds. So that means that I've got 30 seconds of time to process that API request before I'm terminated. Doesn't seem a lot, but let's think about this. We don't want to be writing API endpoints that's taking longer than 30 seconds. I mean, ideally, we want to be getting below 500 milliseconds or even less in order for that to really true. But there are other events that Lambda can be running up to 15 minutes. So you can have a function that can run up to 15 minutes in a single run. And again, we're at a function level, right? So these are designed in such a way that the threading or the parallelism is done at the layer above. So instead of me worrying about how to thread out an individual function execution, I'm now outsourcing that effectively to the container to say, no, you run these functions in parallel as opposed to at that layer. So we talked about cost, and let's have a quick look at what cost means for functions. So what we've got effectively here is it's the number of requests plus the runtime equals your cost, okay? So in the Amazon world, 20 cents will get you 1 million requests, and that's a fixed total, keeps running along. And then you're billed effectively on the amount of milliseconds that is run in the amount of memory that you've allocated to your function, right? Now, this is not the amount of memory your function has used. This is the amount of memory that you have allocated to your function, right? So an example here is for every request that's coming in for a function that's been allocated 128 meg of memory to run, it's going to be, there's like 8 zeros there before we get to actually cost. So as you can see, it's not a lot of money we're talking about here. So let's make this a little bit easier to digest. So let's look at this from a monthly perspective, okay? Now, again, you cannot think of memory in the same way as you think of memory if you're running up a JVM or you're running up an app server. You would never run an app server in 256 meg. Of course, you'd give it like 4 gig or something big, okay? But here, no, we're talking at a function level. So at each function level, 256 meg or 512 meg. And again, these are big numbers. In reality, you know, we run APIs successfully in 128 meg with no problems whatsoever. So looking at this and giving us a rough execution time, etc., we're seeing that there's a lot of zeros there. Why? Because Amazon gives us a lot of headroom in their free tier every year where they literally just don't charge for that. I mean, as you can see, for something that is up to what, 10,000 requests a day in this sort of model, it's not going to cost us a single penny. And think about your timer function that you may have run up a host to run once a day. I mean, it's going to cost nothing. But let's look at the complete other end of the scale. I've got 1 million requests per hour, which translates to around about the 270 mark per second, sustained throughout a whole month. And it's still only going to cost $1,600 with half a gig of memory. I mean, you can run up an EC2 instance of that to handle those volumes on that side of the fence. So the economics is very, very favorable. Now, as a sort of a tale from the field, when we have put in serverless microarchitecture to stuff, we've had CFOs come to us like after a few months and said, there seems to be a problem with the AWS bill. And of course, panic goes to say, oh, what have we left on? What's running up the bill? And they'll come to saying, there's usually more zeros at the end of this. What have we done differently? I said, perfect. We're only getting paid for what we use, not what we provision. Big difference. And that truly is a cloud native application at that point in the game. And that's what makes it really exciting at that point. So again, what you discover is that you may not be actually using your app server or your request as much as you thought you were. And when you start going into this world, things free up quite a bit. Now, there are some limitations. I, first of all, thought, hey, there's limitations, but really, they're guidelines, okay? These are good things that you should be doing anyway in order to make sure that you're a good steward of writing server-side code. So memory size, for example. Okay, so memory size, we can go from 128 meg right up to 10 gig, right? So you can provision a 10 gig function. Now, that's a lot of memory. Now, you're not going to do that for an API gateway because loading that much data into memory for a start is going to probably take more than 30 seconds. But again, we don't think of this memory in the same way as we think about it for an app server. So small is better. Execution time. Again, we've been already noted that you're going to get terminated. There is no such thing as sort of being run and you don't have to worry about a function that never returns because you're going to get billed for it. No, you're going to get a maximum of 15 minutes if it's anything other than an API gateway request, which is only 30 seconds. Okay, so again, good provision to make sure you never hit anywhere near that total. Another one that's a little bit of a surprise to new developers coming into this space is you do get some disk space. You get 512 meg of disk space hanging off the temp partition, and it does persist between function calls. Now, when I say it persists between function calls, think of that as a side effect as opposed to something you would hang your hat on. Okay, so an example would be maybe you've done some caching of something and you want to page it to disk instead of memory. You can put it there. Now, it may not be there the next time that function is called. In reality, you sort of forget about it between function stuff. But if you're doing something whereby you need to page stuff out to disk while you're doing something, it's a perfect space to do that for. And then you maybe upload it to S3 elsewhere, etc. as well. You can attach other Amazon file storages onto that in order to break free of that and do get persistence, but that's a whole different ballgame after that. Our deployment size, okay, again, we're thinking functions. We're not thinking what you would have given to an app server, so you want to keep them small as possible. The first limit out the gate is 50 meg size, so that's all the size you can have for your jar file. Now, again, you can get around that using layers, which is a technique to be able to park common code, and just where you park your common libraries, etc., into that layer code. But all that does is add startup time, not a huge amount, but again, keep to the principle that the function you deploy should really only be having the code in it that's doing that function code. Get rid of all the fluff. And concurrency. Out the gate, we're limited to 1,000 concurrent requests of that function again. It's a lot. We've only ever had one instance where we've had to up that, and it's a quick email to the support in AWS to say, hey, we need a bit more, open up the tap. And again, your functions are designed to run quickly and fast in such a way that you shouldn't be needing this amount of concurrency if it's going out. Now, we're not all running eBay or Facebook, so cautious there. So that's there. So now we're going to flip over and look at some real code and see where we go there. So thank you very much, Ryan. Seamless there. So let's look at some Java code here, see what we've got. Now, this is IntelliJ, and a serverless project is fundamentally a very basic Java project. I mean, we're back to the Pojo way of working again. You know, there's nothing complicated here whatsoever. It's a bunch of Java files, and it's a basic Maven project. Okay, so if I look at my Maven project, I've only got a handful of dependencies. So my dependency here, of course, is the Lambda core, and that's going to get me some of the functions that's coming in from AWS. I've got my log4j for my logging there. We'll talk about logging in a moment. And then I've got my event stuff. And again, I've got a jar file here that's going to do both SQS as well as API requests. So Normally, I wouldn't have both of these in here at the same time. And then finally, I'm using the Google JSON library for my JSON decoding in and out there from that perspective. So let's look at a very simple one here. So this is get time, simplest function at all. Now, what we've done here effectively is I've made life a little easier for myself, because usually it's an enter. So we've got an endpoint handler. And this is effectively as easy as it gets, okay? We have an interface, and these are the two events that are coming in. We've got basically the request event and the response event. Implements that. Again, very similar to a servlet. I mean, you've got your request response coming in. And I've just created a couple of helper functions here to make life a little easier if I'm going to continue to be doing this sort of stuff. And this, again, there's room to experiment and through yourself. So effectively what we've got is we've got to implement this guy here, right? So we've got a context that's coming in that's going to give us context over the overall Lambda environment. And then we've got details of the event that's coming in. And then our goal of this function here is to return back a response body, okay? Now each of the different events have got slightly different signatures for that. So, and if we look at an events, a response object that we're sending back, again, this is an HTTP response. So again, we're looking at an API gateway response coming from the Amazon library. And really, there's just a couple of helper functions here that I've added to this. You can reuse it out the gate, but again, it's just a couple of stuff here to set all the headers here to make sure that it's easy to get around cores, for core support, and a couple of things here just to make things a little easier, like if something throws an exception, to package up that exception, set it as a 500 status error, and then add the message of the stack exception to that code. And here's a simple one here just to throw bodies off. So nothing complicated here. So let's look at what it actually looks like. So again, standard Java class, nothing complicated here in the slightest. We're extending from our endpoint handler, which is nothing more than a quick facade over that sort of stuff. We define our logger. Now, there is logging in Lambda, but what it effectively is, anything that goes to system.out makes it to CloudWatch. Everything else will get ignored. So if you've got a logging library that is configured to log to files, you're never going to see those. So it'll never get there. It's got to log to the system console in order for it to get to the console there. So here we are, we're implementing this. We're just doing a quick log stuff so we can see it coming through. We're going to get a response body out. We don't know what we're going to do with that response body. And here we're just going to put in some times. And if it does throw an exception, which, I mean, this is not going to throw an exception, of course, but it's more for illustration. Instead, we're going to say, right, no, we're going to log the exception. We're going to set the body, and then we're going to return the response. It's that simple. It's that simple. So if we go here, we can build our Maven project. Again, no mystery here at all. And what that has done effectively is it's created a jar file. We'll not talk about the other two jar files at the moment, but it's created this jar file here. And what we've got effectively is a single jar file. It's taken all the dependencies of the other jar files and made it into a single jar file. So here we've got all the Google stuff, as you can see, but here's our code. And there's the get time class, okay? So now that's done. So what do we do now? We've got this jar file here. Now we've got to get it up to Lambda. So what we're using is we're using the serverless framework. Okay, so the serverless framework is a nice little packaging framework. I like to think of it as like Ant for Lambda, but effectively it takes the configuration of what you need to do, and it creates effectively a CloudFormation template, and then uploads everything and then installs it to Lambda. So what we do there is LSS deploy. We're going to look at that. And this takes a lot of the headache out of everything here. So now what we're doing is it's uploading the CloudFormation template. Now if we go back into here, we're going to have a quick look at here's the. So if you're familiar with AWS, you've done anything in that sort of stuff. CloudFormation is effectively the secret sauce that makes a good cloud infrastructure work. I mean, you should never be going to the console and creating these resources. You should always be done through code, whether it's Terraformer or CloudFormation, etc. here. So if we go back to here, it probably is done. No, it's still updating this sort of stuff. So we've got a small stuff. Now here we go. So we've now been deployed. And here we've deployed 3 endpoints. I'll go through the configuration of that in a moment. And we've got 2 endpoints hanging off a GET, and that's been pre-configured with the API gateway. Again, we've not had to go into the API gateway to do anything. It's been done through the serverless framework here in order to do that. And we've now got our get time here. So if we go to here, we hit the response time. Now notice it takes a little bit of time there to get started. And because the Lambda is cold, that means it hasn't been loaded in yet. But if we go now, we can see it's pretty much instantaneous at this point in the game. Okay, so let's look behind the covers. Okay, so if we go to CloudWatch to begin with, let's look at the console. So this is effectively the console that came out. So here we've got effectively everything that was logged, the system.out print line effectively comes here. Okay, and from here we get to see what it is. So we see, for example, there's our handler. That was our log request. And these 2 here is what Amazon puts in as part of their starting the request and getting at the request. And again, they've got a unique ID that identifies the request. You can get at that through the context object, which we'll show in a minute. But here's the interesting piece. So here's what it cost us. Okay, so effectively, as we can see, it was a cold start. It was the first time this Lambda was fetched from S3. It was the first time it was loaded into memory. So we had to spend a little bit of time to get there. And it basically took us a second to get that up and running. And we're billed to the nearest millisecond. So we're going to get charged 1,022 milliseconds at this memory size. Okay, that's a lot. Feels like a lot. Okay, but as you can see, most of that time was spent getting started. Okay, but let's look at some subsequent requests after that here. So now we're back down into being only billed 15 milliseconds, 18, and here's one at 3. So as you can see, if the Lambda's warm, it's hardly anything. And again, this can scale up quite dramatically on that respect. And it's exciting. Sometimes you'll get a little bit of a disparity, etc. And a bit of a black art as to when the Lambda goes cold, when it needs to be loaded in. But effectively, we've discovered if you keep hitting it at least every 5 minutes, it's going to stay warm on that front. So that's now the CloudWatch stuff. Now again, let's take some of the mystery away. Let's go back to IDE and let's look at the serverless YAML file for a moment. So again, this is very simple, very easy. It's a nice way of laying out effectively what is going to be our way of uploading our Lambda on there. So we've got our AWS ID account. The serverless framework actually does support Microsoft and Google and many other ones there as well. So again, you can use the exact same template to drive those ones. That's what makes this a really powerful function. Which region are we deploying our Lambda in? Which runtime are we using? We're using Java 11, and the underlying JDK is, of course, Amazon's flavor of Java. We're saying default memory size is going to be 256, and we're going to default our timeout to be 15 seconds. We're going to retain our logs for 3. Now let's get down to here. This is where we attach our function onto the given events here. Okay, so here's one, for example, for our get end time. So we're basically saying, here's the full class path effectively to the handler. And this is going to be the URL or the URI that's going to be hanging off of that here. And as we've seen with the deployment here, the API gateway assigns our account effectively our own here. Now, this would be the one that you would CNAME onto as part of an overall stuff, because you're not going to advertise this URL out to the world again. But again, notice it's the HTTPS, you're secure out the gate before we even get started there. Okay, so now let's look at how that looks here. So again, there's no mystery here. All that has done is effectively compiled. It hasn't compiled, Maven compiled. It then basically created all the CloudFormation templates, hooking into all the different resources that we were going to use and move it up to S3. So here we've got the Lambda here that's registered. Again, this was all registered via that SLS deploy function. And again, you see the functions here. That was the size of our jar file that's here. We've got Java 11, which we specified. There's our handler, and that's it, ready to go. Okay. And if we look in the API gateway side of the fence, it'll be there also as well. And here's the CloudFormation template that was uploaded. So again, there's no mystery here. I mean, that's effectively the exact same file that you're seeing here. Okay. IntelliJ has formatted it a bit nicer, but it's the exact same one there. Okay. And this is where it really becomes powerful, because if your Lambda needs access to, say, an S3 bucket, then this is where you'd put in the role and say, right, I need this to be connected up to there. And this is where you do all the security plumbing from this side of the fence. As part of the SLS or serverless framework, it basically deploys your code to an S3 bucket. That's where the jar file lives. So it'll create this bucket in your space. And again, there's no mystery here. Dig on through Java conference, dev environments, and here's the latest one here. And there's that jar file there that's sitting there. It's the exact same one. There's our compiled CloudFormation template. Okay. So again, this is a nice little touch that if you feel like your Lambda is not getting updated for whatever reason, you can jump into the console and start seeing exactly how things work on that respect. So that's the overall sort of autonomy of a function, a very simple layer. So let's look at some other examples here. So let's look at one that sort of exposes some of the more interesting responses here of stuff. So what we've got effectively here is one that just echoes. It's a post. It'll bring in whatever it's got and echo it back straight out again. And as you can see, getting at some of the things that are associated with an HTTP request is made easy for us through these helper methods. Okay, and these are part of the AWS SDK. So instead of us trying to figure out how to get, say, for example, the body out of the text and all that sort of stuff, it's handled here in nice methods. Now, remember when I said that a Lambda has got a finite amount of time to run? This little function here can be called as many times as you want inside of your function call, and it's going to tell you how many milliseconds is left before you're terminated. Very handy, particularly for queue processing. So what this is going to do is effectively, this is going to return back something that will tell me how much time I've got left. Okay, now we know we've got a 30-second maximum time for an API request, but I set this to 15 seconds. So if I go back to here, we're going to look, this is my UI for this. Now, I know you're impressed. So source code will be made available for those that wish to look at this sort of stuff. So what we've got now is, let's just ping it with something. Loading up, and here we go. So there's all the headers that came in. Again, very familiar to anybody that's done this type of processing before, etc. But notice the one here. This is the mirroring time. So that's basically saying we've got 14,000 seconds roughly left before we start going to be terminated. And again, very useful on that front to let you know when it's going from. So that's handling a post request. Okay. And we set that up here by saying anything in the echo and any method, whether it's a post, delete, put, get, is going to be handled at that level there. Okay. So let's look at something a little bit more interesting. Let's look about the life cycle of these Lambdas. Let's have a look at how this all works underneath the covers. So here we've got our standard endpoint handler here. Now let's pretend we're going to be clever. We're going to throw up a thread. Okay, let's start a thread off in the background and let's see what happens. Okay, so we're going to, of course, our constructor gets called. Okay, because that's how Java class lifecycle works. So we're going to get stuff there. We're going to do something here. Then for each response, we're effectively going to peek into that thread and toss out its thread count here. So, and again, this is not a class thread here that's going to pass any sort of Heinz quality metric here. It's just going to simply, for every second, increment a number. Okay. Now, if you run that if this was a servlet and you ran this in a traditional web app server, you'd expect that thread to keep running and keep moving along. But let's see what happens when we kickstart it off. So let's go into the life cycle now. Okay, there's it's running. Let's repeat. 1 elephant, 2 elephant, 3 elephants, 4 elephants. You expect the thread count to be more than 2 at this point, wouldn't you? Oh, what? Why is it only 3? 6 elephants, 7 elephants, 8 elephants, 9 elephants, 10 elephants. We can go as many elephants as we want. Oh, the thread's here. At some point, the number of elephants will make no difference. The thread count will go back to 0 again, right? So what's happening? What's happening? Effectively, what's happening is as soon as your request is finished, your container goes into a freeze state. It's effectively terminated, okay? Now, if we go and look at that in the CloudWatch world, we can see this life cycle operate, okay? So there, as you can see, there's our constructor being called. Boom, done, nice. Now for every request coming in, 12, 13 milliseconds, notice the constructor's not called again, so effectively that Lambda's gone into a freeze frame mode and is stopped now at that point. So therefore, threads inside a Lambda, not a good idea. They get you nothing, okay? And if you're at a stage of where you're needing to thread out something inside a function, then you probably want to think about that a little bit and re-architect your function in such a way that it's, you'd want this to be called as if it was part of a thread, as opposed to threading out inside of the function. It's going to make it easier for you to scale out and not have to worry too much about the logistics of figuring out how some of this stuff works. So we did HTTP requests. So let's switch gears and go over to queues. Okay, queues are the secret sauce of any enterprise. It's what makes things really work. Now, again, this is a very simple handler that will pull off a message from, which will be called in response of a message from an SQS queue. This time, we've got a request handler that passes in effectively an SQS event, and we've got our context there as well. So our context, again, if we look at the context, got a lot of good goodies here. We've got we can find out the AWS request ID. That was that string that you've seen in the logging file. So again, if you're going to be pushing this into other log stuff, it's a nice way to keep your log files together. You've got your function name and your function version number. Version numbers are something we can talk about at a later date. But again, here's our get remaining time stuff here. And again, the get logger. Again, that's just a handler to effectively a quick way to get there. The get logger doesn't really give us anything other than log. I mean, that's it. So in many respects, sticking with some of the old classics, fallen out of favor of late, but the old classics still work here on that front here. So we've got a very simple queue that's going on here. Now let's look at how we plumb this in to a queue. So here we've got back to our serverless file. Again, makes it very easy. We've got our handler, which again is full class path to the class file. And then we've got this ARN number, address resource number, I believe it stands for. Ryan will correct me for that at the end here. So this is effectively the unique URL to the handler. And if we go back into our SQS world here, we can look at the queues. And if we look at the queue here, this is this one here. Okay, so I'm just copying and pasting that ARN number, putting it into here. And then we've got this wonderful thing called a batch size. Okay, so you can set up your Lambda that'll get called for every function, every event that's on the message, right? But you can go up to a maximum of 10 items, which basically means it's going to fetch 10 items off of that queue in one go and deliver it to your endpoint. So if we go to, where was it? Queue listener. So that's why we've got a for loop in here, because we're effectively saying this SQS events could be multiple records, okay? And again, as we go into here, we get the message body, and we have a quick look at what's available to us in the message body. We've got a whole bunch of meta information to tell us know which queue it came from, what type it is, how big it is. And here we're just going to do a simple get the body out of it. We're going to assume this body was a JSON body. So we're going to convert it back into a map. We could put it into any of the other classes that we want. I'm just going to log it. That's simple. That's simple. So if we have another look at running that, we'll go back to our AWS console, and we'll just create a simple message that we're going to toss to the queue. End message, boom, gone, right? How do we know it's processed? Back to our old friend CloudWatch. So if we go to log groups, there's our SQS example. Look here. And there we go. There's our message queued there. And again, cost us 153 milliseconds on that go. Now, again, it was probably a little bit cold. So let's send it another message. Send it some more messages. Let's have a look at the CloudWatch now. Now, it'll probably wait until those turned up, and then it starts to go. Now, look at how far it's fallen now. We're only getting like 2 seconds, 2-3 milliseconds now. So as you can see, there is a bit of a tax that you have to pay, and that's the startup tax. It's getting us to the point where it's going into memory, and then we're now moving forward on that front. But as you can see, it's now going through. Now there was a little delay there, right? Why was there a delay? Again, these are other configuration options you can put into the serverless file or the CloudFormation template. And that basically was saying to the underlying agent that was going to hand it off to your Lambda, could you hang back a wee bit and see if something fills up in a given period of time before you hand over these 10 functions, okay? In a fast environment, it's going to be coming all the time, okay? So a common technique that we do, for example, if you've got a compliance thing where you need to be logging every API request that's coming in, instead of spending the time logging the request inside of the handler that's coming in, what we would do is effectively, we'd process the request as per what's needed. And then as part of like a finally clause, we would then push that request body out onto an SQS queue. So we're basically saying, right, that can be processed later. I don't need to use up the time processing that now. And besides, logging for compliance is a completely different mindset to what I'm doing with the business rule for this particular function. So they don't actually even live together. So that allows me to break apart these processing, and by tossing it out onto a queue, and the queue can be persistent, so I don't have to worry about something living and breathing and responding there and then. I then process that queue as and when the Lambda is going to wake up and do things with it. So that allows me to effectively offload stuff there. And again, that relationship between SQS and Lambda is one that you'll probably use a lot of. And again, there's a number of different services inside the AWS world that's going to do that. So what we've basically gone through there is a very simple Java project, standard Maven. Can be anything really, it's just something that's going to compile a jar file, let's be honest with you. The serverless YAML file, the serverless function, again, there's going to be URLs, bookmarks, sorry, to all of this stuff. Again, it's a very simple framework that gets you up and running. There's nothing complicated above all. And as you can see, that's about as complicated as most of us ever get in terms of deploying it. And that's going to push it up. This is a nice way of controlling things. Done and dusted. And then really our actual Java code itself is really very simple. I mean, truly, truly simple on this front. So nothing there on that. So Ryan, can you switch me back? Thank you, sir. So now you've seen how easy it is. Let's look at where else this is hanging out. So in the AWS world, and I know this to be the case in Microsoft as well, as they're getting more and more into that, Lambda is everywhere, truly is everywhere. You can hang a Lambda event off of anything and everything. So we've seen, for example, the first two API gateway and SQS, but you can do it off the notifications. S3, for example, anytime anybody uploads. So another classic example is you've got a user that uploads an image into an S3 bucket. You can have a Lambda function that gets triggered after that upload automatically that will then go and process that file. It may move it, it could go elsewhere, do something with it. Kinesis stream, which is app processing, which again, or Kafka, you can hook into that. Code commit, I mean, a perfect one to hook into if somebody does something that they commit into a given branch or a given stuff, you can have that Lambda then run up and go and do something. Wonderful. You also have it as a timer. So there's like a cron tab functionality with that serverless function where it literally looks like a cron tab entry where you've got like 8, 4, 5, to run up at 8 o'clock every Sunday, etc. And your Lambda is going to be spun up every time there. One of the real cool bits here that has been an interesting one, if you use Amazon's Aurora Postgres service, you know the way we can hook effectively a stored procedure onto a trigger event of a database. So if something inserted or updated or deleted of a database, then that stored procedure is going to be triggered and executed. You can actually attach a Lambda to that now. So now every time somebody does a delete, your Java Lambda could be running to do something with that delete. It's wild to think about all of that side of the fence there on that front. And again, the DynamoDB is very similar to that. Again, it's kind of like, it's like hooking observability into every part of the ecosystem. It makes it very, 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 very powerful. So as we're sort of coming into the end here, let's talk about some of the best practices in order to make sure you've got a successful Lambda environment. Keep it small, fairly obvious, sort of banged on that drum a couple of times throughout this, but truly keep it small. And that's both in the amount of memory that you think you need. And again, it's trial and error. Do not go off of any of your ways at how you'd have tuned the JVM normally. Think about more tune the function as in its own little world. Keep your packages small. So again, we had that 1.7 meg that was uploaded to S3. You really don't want, you know, a 40 meg file sitting up there being pushed back and forth all the time. Keep it small in order to keep the load time very, very small. And speaking of load time, because you're not charged for Lambda that's not being run, AWS or the serverless container has the right to basically unload you, for the want of a better phrase. Okay, so that means it can go cold. And cold simply means that it's going to take a little bit of time, a little bit more time than normal to bring stuff in. Okay, so again, you can keep this Lambda warm by sending dummy messages to it. You know, in the old school JMS world, we would often send null messages throughout the system, A, to make sure that it was still working, and B, to have the confidence that when the messages do come in, that they were going to get processed. So again, some of that old school techniques will kick in there as well. Configuration stuff, right? Do not put configuration file information inside of the Lambda. Let the Lambda go and reach for those configuration files from an external service. SSM, the security manager in AWS, is a perfect place to put database credentials, for example. Stick them there. As we've seen, do not use threads. Threads are not your friend in this world. Again, think at a much smaller micro level. Threads is what's effectively going to be running your functions as a whole over and above that. So instead of trying to be clever with your threads internally, instead think of your Lambda now as what would have been a thread execution, and think that way. It does make life a little bit easier for you, as you don't have to worry about locking and synchronization and all that side of the fence. So in many respects, it makes a scalable application truly scalable on that respect. Here's one that's contentious and sometimes gets us into a flame war debate. Don't do connection pooling. Connection pooling will be a monkey on your back when it comes to scalability and redundancy on that front. You want to keep it simple, okay? So what does that mean? It basically means every time I need to talk to the database, I'm going to open up a connection to that database there and then. Okay. Now I'll cache that request, that connection pull for the duration of the function call and then close it down again. But I'm not going to cache my connection request between each one. Why? It's a very simple reason. One, the database to which I'm connecting to, it may no longer be there. Because remember, in cloud land, it's not if something goes down, it's when something goes down. So you have to build for redundancy from the scratch. A good cloud native app means you don't need disaster recovery because you've already built it into the original architecture. So therefore, don't assume that the database is always going to be where you are. So between function calls, it could move. It could be a different SQS queue that you're pulling from. It could be a different SQS queue you're pushing from. So don't get too clever on that respect. And finally, as you can probably figure out, don't get too smart with your function. Don't try and do too much. Remember what I said beforehand where, for example, we're logging stuff for compliance reasons? The compliance logic has got nothing to do with the function logic. So push it off into an SQS queue to be done elsewhere at a later time. Don't do too much. Now, there are times you do. Sometimes you can drink at the fountain here too much and say, right, if I don't need to worry about servers, how can I not have any servers in the ecosystem? And there's two ways you can do that. Okay. Technique one, which is the old school way of serverless, which is basically splitting up your job into smaller jobs that can be handled in a 15-minute window. Okay. Now we've done this before for, say, for example, processing importing files where you would effectively split the file up, put it into S3, pull down the file into S3 using your temporary storage, run through it up, keep running through the job to see, do I have enough time left in this execution? Yes, I do. Let me do it again. Let me do it. No, I don't. Push it up to S3 and get moving down. That works. It's a bit kludgy, but it works. Now, technique number two, using Fargate, which is a new service from AWS. I say new compared to the old school stuff, but Fargate is a wonderful, it's basically a serverless micro container architecture. And that basically allows us to spin up a JVM in real time and be billed on a per second basis and then come straight back down again whenever it is, right? We utilize Fargate a lot for housekeeping tasks. If we know that we're going to take longer than 15 minutes, if we've got to run through a whole bunch of databases in an enterprise, etc., we'll run up a Fargate, etc. And again, Fargate is one of those solutions whereby it's kind of like where you would have those utility programs you've written and you say, right, I need to run this job on a host somewhere that's running in production, and 9 times out of 10 you'd create an EC2 instance and you stick it there. So right, I'm going to run this up here. Just get rid of all of that sort of stuff. You don't need to keep a sort of like a host hanging around to do such jobs, right? How many times have we backdoored stuff onto our build machine or our Jenkins machine because it's just handier because we've got already a machine hanging there? Don't need to do that with Fargate. Fargate makes it really simple and easy on that front. A Lambda is not a war file. May seem obvious, but it's worth repeating, okay? The Lambda jar file is only Java class files, nothing else. Yeah, you can have other resources in there like .SQL files if you're going to abstract out your SQL queries into a file, but they're not war files, okay? You now got to think of static websites, okay? So gone are the days of using JSP now as a server-side language. You've got to think a little bit more API-driven. So that means that your Lambdas are going to be exclusively doing API responses in a web world. And now you're going to push off effectively your HTML, your CSS, your images, etc., over to a CDN on something like CloudFront backed off of S3. What's nice about those two worlds, there's no servers to be managing. I mean, it's truly scalable as and when the requests come in. Let's have a quick look at that. On the left-hand side, what we'd effectively have is somewhat of the sort of the JSP model. Okay, you've got requests coming in from the API from the internet. They're going to go through some sort of load balancer to get it routed to an application server that's running here somewhere, whether it's JBoss or something, and you're going to have a pool of these sitting there waiting for the request to come. You're going to at least have one, maybe two for redundancy. And you have to figure out what the triggers are. So when the load balancer is coming in with more and more requests, what's going to be my threshold for running up another web server? How long is that going to take? And then I've got the logistics of bringing that web server back out again. Now, this was stuff that we've all grown up with, and this is what we did. We know how to do this like the back of our hand, but it's a hell of a lot of maintenance, and it's a hell of a lot of cost for what's effectively no gain. Look over on the right-hand side. Web developers, they want to be more in a React world and a more Angular world. They don't really want the HTML page to be already created on the server side and then delivered. They kind of want to do that themselves. So web development has sort of moved into that world of where we'll do this ourselves, but we'll use Ajax to effectively call the API calls to build up the page. So now we can use the CloudFront and S3 mentality to be delivering our web assets. And again, there's no servers for us to manage there. We're going to get charged on a per cost basis, request basis. On the left-hand side, I've got my API gateway, my Lambda function, so it's going to be charged on a per usage calls. I mean, there's no servers there. Yes, we've got our database server there, but even then, choose the service wisely in AWS, and you can eliminate that part for your ecosystem. Okay. We have installations where the only server that we've got running up is the one that's running SonarQube. That's it. Everything else, there's nothing there to manage. And that's really, really appealing from that side of the fence. So back to the original side of the fence and all the fluff. So basically serverless Java, it removes all the container logistics and all of the issues that's usually associated with that, and all of the ickiness that we had to get involved in, and lets us scale up automatically. Okay, that's somebody else's problem. You know, at the end of the day, I've got a function to write, and this function is going to respond to a given API call. If there's a million of those coming in or one of them coming in, I'm going to do the exact same thing. But really, as a Java developer, take me out of the scaling conversation. I'm going to leave that to people that are way more intelligent and can manage this way better scale than I can. And that's where I rely on the AWS and the Azures of the world to be able to do that sort of stuff. I don't need that overhead in my job to get this done. And in many respects, we're hard pushed to figure where an app server can really come into play these days. I mean, there's still a place for them, not saying that they're out, but it truly has become a state of where, do we really need that Tomcat? Do we really need that JBoss? What's it really giving us? And it's a good question to have and to ask yourselves. I'll put this presentation in part of the GitHub side of the fence, and we'll update the stuff. But effectively, here's a lot of good URLs to things I was talking about in the talk. Pay particular attention to this one here, the one at the end. A very good in-depth conversation about how Lambda works behind the scenes and how it does that container, how it does the termination, how it does the loading, the cold start. Fascinating. It takes a couple of read-throughs before you get to truly appreciate what truly is going on here. And it is a very impressive technology on that front. And with that, I'm going to bring in my friend Ryan, and we're going to answer some questions.
Hello again, Alan. All right. So we've had a very active comment session while you've been talking, which thank you again for that. So effectively what I'm going to look to do here is just kind of go through the questions. So if you've asked a question in the chat, I will say who asked the question and then basically present the question. And then Alan and I will answer it to the best of our abilities. So first, I do want to do one thing, which is, since you asked me to correct you, ARN stands for Amazon Resource Name.
Thank you.
Sorry. So our first question is from
Never
Amir.
be the smartest man in the room. That's what I say.
Is there any special integration or end-to-end test when it comes to serverless? For example, are there any new opportunities now by using the serverless?
This is for testing.
So basically, one of the earlier slides you mentioned the whole serverless makes it easier to do testing. So specifically, when it comes to integration testing, end-to-end testing, what do you recommend, or what makes life easier with that more specifically?
Well, I mean, the good old-fashioned JUnit comes back into play again. I mean, it truly has. You know, it's a steadfast library and part of all of our Java utilities. But and again, any API type sort of stuff. But again, at this level, you don't need to necessarily test from the API side of the fence in terms of, do I need to be testing the raw JSON that's coming in? Yes, you do. But the reality is you can mock up, and that's why everything's an interface in this world. You can mock up all of those functions, and there are a number of open source libraries that have already done that to allow you to do that easily. The serverless stuff allows you to run your Lambda as if it was in a Lambda container inside of your own local machine. IntelliJ also allows you to run your Lambda locally, and it does that as part of a container in a Docker effectively, and it runs it up there again. Again, that's a lot of overhead. It works beautifully. You know, historically, what we've done effectively is we've just mocked up our own interfaces for the test cases we've done and just run it through JUnit. And by running it through JUnit, you're going to get all of the tools and the reports that come from the JUnit ecosystem through your testing. So think of your Lambda like a plain old Java object.
Yeah, I think the only two things I would add to that is effectively with the implementation of kind of the serverless and keeping your functions very small, it lends itself to kind of the integration testing or the JUnit testing a lot better, because now you have these nice discrete little functions. So you're testing that discrete function, whereas historically you can get yourself to sort of this bloat situation where you got a lot of application around the function. And so you wind up having to test a lot bigger function than you're concerned with when you really just want to focus on one piece of business criticality. And then
your coverage metric will become a lot better.
Yeah, you're covering the points that you actually care about a lot more. And I would say the other part of that is there's plenty of other frameworks around that, like even serverless. Serverless has like plugin support. So one of them is called Serverless Offline, which makes it very easy to effectively run almost like a mock API gateway or a mock whatever, where you're running your Lambda functions locally. So there's a lot of support. I mean, this is becoming a rather large community. So there's a lot of third-party support and plugins in this world to make that easier. Right. Moving on to the next one, we have one from Karam. What are some practices to deal with authentication and authorization for functions as a service?
Oh, that's a wonderful question. Again, security is something we could spend a whole hour in by itself. Effectively, one thing that we didn't show is that there's a whole wonderful way of authorizing your Lambda before it even gets to being called. Particularly if you're going through the API gateway, there's this thing called authorizer. Okay, and the authorizer is effectively yet another Lambda that's called, and you can think of that Lambda like a pre-Lambda that's called before every request that comes in. And that's a perfect example for you to be able to do, say, for example, JWT inspection to make sure the JWT token that's being passed into you is correct, it's not expired, it's not got things in it that shouldn't be in there, for example. And effectively, the JWT token is another wonderful technique. And again, we could spend another hour going into this world. You know, in a typical servlet or an EJB type environment, you would park a lot of data into session variables, and that's lazy in many respects. It also makes it hard to scale out, because now you've got to the point where either the app server's got to mirror those sessions across each of the servers potentially, or you're always being packaged into that one there, right? It was really a bad way of doing things in the first place. We probably shouldn't have allowed it. Instead, you could park that data over in a Redis cache or something else, or you park that data into JWT token and have the token come back and forth every time. But no, security is something that's done very well, and you can also restrict your Lambda. So the execution there, for example, our Lambdas, they had open access to the world there, but in reality, Ryan would never allow that to be even deployed. You know, you effectively define the roles and the groups to which that Lambda is going to play in, and you literally control it at the AIM level as to what that Lambda can do. So that Lambda cannot accidentally go into a bucket it shouldn't do. Can't accidentally talk to a resource it's not allowed to. So that gives the DevSops side of your brain full control and much more granularity as to what that function can do, but basically allowing the developer not to have to worry about accidentally doing something they shouldn't.
Yep. Great answer. I don't have anything to add to that one. Next one is from Amir again. Since JVM doesn't run for long, isn't Grail VM a better choice with serverless?
That's a discussion outside of this, but thank you.
Yeah. I'll comment on that one. We don't have much direct experience with Grail VM, so I can't speak to it directly. I do know Grail VM does tend to run much faster in certain situations. I think the only things I would say here is obviously do some research. I know with AWS Lambda is by default, you only have basically Corretto support. So it supports Corretto 8 and Corretto 11, which is the Amazon flavor. Obviously, you got the other cloud providers that are going to have their own support for different things. AWS Lambda does have support for building your own custom runtimes. So it's effectively you're building your own kind of little execution container. So in that situation, I think you could probably set up a Grail VM, but I'm not going to say that's going to be an easy path to go down. I'm not going to say it's not impossible. I'm sure there's articles out there that outline how to go about doing this sort of thing. But in our experience, we can't say directly one way or the other if that's going to help you. Moving on to the next one, I think it's Matthias, and I'm going to go ahead and apologize now for anybody that I mispronounced their name. I'm a bad name pronouncer on the best day. Considering cold start, is Java a good choice to work with serverless, or is Python, JS, Node, Go a better approach?
It's a good question, and to be quite honest, in full disclosure, the vast majority of our API endpoints is delivered in Node. Okay, and it's not because we prefer Node. I mean, anybody that's worked with JavaScript for any amount of time will be tearing their hair out at some of the things that you can do in JavaScript. No, it's more because the vast majority of API endpoints is really reading and writing from a database. There's really not that much more complication to do, and some of the libraries in that side of the fence is pretty rich. And frankly, a Node endpoint has got a significant less cold start compared to a Java one. Now, that said, anything that's financial related, anything that's off an SQS queue, anything that's richer, we generally do in Java from that side of the fence. So again, that's what's really kind of cool about the whole serverless environment. You use the right tool for the right job. Okay, so that includes C#, Python. I mean, you already listed them all, but fundamentally, Node is a good example for stuff there. Now, but again, if you've got endpoints that you really want to make sure you've got the floating point to the right number, that 2 + 2 does become 4 as opposed to 22, then you'd probably want to stay with Java.
Yeah, I think you hit the nail on the head there in terms of, I think the main thing there is with a good serverless architecture, you do choose the language that fits the bill. So we tend to use Java for the things that Java does very well, or if it's this case where Java just has better library support, like we tend to a lot of times do a lot of PDF production on serverless using Java as opposed to Node, just because there's some richer like Apache PDF and all the other ones that just gives us a richer library to use from for certain applications. Next one is from Awa. Can you give us some practical examples of what problems you solve using serverless?
Practical examples, the timer one is perfect. I mean, when you've got things that need to be run up at like once a month, once a week, once a day, not even worrying about finding a machine to park that on or figuring out a spot instance you're going to spin up or an EC2 instance you're going to spin up or making sure that, hell, is that machine still running in order to run? Have I missed my window there? Oh, that has been huge on that respect. Other things, of course, API requests. I mean, really simple in that stuff. When you want to get into some of the real fancy CI/CD stuff, for example, hooking lambdas off of code commits and all that side of the fence can really trigger certain things. So, for example, if you've got a piece of code that you know, right, this is handling security or encryption, and if somebody starts to fiddle with this code, then please email the chief architect that somebody's twiddled with that code. Very simple. One thing that is used quite a lot of, in all fairness, is CloudWatch. It's not a great interface, let's be frank. So, but that's where all the logs go to. Good use of a Lambda is to bounce those logs straight into an Elasticsearch. And again, those logs could be logs coming from other things other than Lambda, of course. Those CloudWatch is effectively the logging for AWS as a whole. So again, you can use a practical Lambda to bounce that into Elasticsearch and get a holistic view of your enterprise in a single logging tool.
Yeah, I think from my side, the key point with where serverless really starts to shine is if it's an event, then you don't have to worry about writing the application code to handle the whole grabbing the event. And what do I do with that event when I'm done? Do I need to delete it? Do I need to remove it? Whatever that event may be, you don't really have to worry about the framework code around that. Instead, again, it's back to that whole, you're just focusing on, once I have that event, what do I need to do with it? So it keeps your code nice and kind of simplified. Right, next one would be from Alexander. And this is more of a comment as opposed to a question, but I think it's an important one to kind of talk about. I see two problems with functions. One, you had one app and 10 microservices. Now you have 100 functions. And two, what if they have to interact with each other? It must be management hell, effectively, in terms of having all these functions having to talk to each other.
That's a great question, and there's wonderful techniques for getting around that. And in many respects, in the microservices architecture, we've got that same problem there, but at a different level. I mean, that's the overall holy grail, or how big should a microservice be on that respect. Now, again, here, so in terms of, would you have a Lambda API calling another Lambda API? No, you probably wouldn't, and that's bad practice, okay? What you may do, however, is abstract out some of that common code functionality and have both of them hit that common function if it was like a common library there. Or you put that back to the workflow of the person that's calling the API. Say, okay, well, you need to call this API and then call this API. And if it's an internal stuff, that's relatively easy to enforce. But most of the time, and one of the other things that we do, of course, is we don't generally deploy a single Lambda to a single endpoint, right? So in my example there, we did the echo one and the get one, right? What we do is we deploy groups of Lambda there, right? So what we do effectively is we would have one Lambda that would be deployed, say, for example, the person object, okay? And that Lambda would maybe advertise 4 endpoints. Say, right, this is for the getting, the updating, the creating, and the deleting of a person, okay, whatever entity it was. That meant that those 4 endpoints were controlled by a single Lambda, okay? And in Node, for example, we'd use Express.js to do the internal routing as to what it is. In Java, we can use a number of other different techniques to figure out what the URL path is, etc., and make that clean. There's a number of libraries that do effectively like a Express.js for that. But again, you're now deploying a single Lambda to do groups in an API-driven world. And then you can do the exact same thing for SQS. So again, if you've got like 4 different queues, they're all roughly doing roughly the same thing. You deploy basically a single jar file, but they're deployed to each of the 4 different queues, and they're just doing different endpoint calls inside it, but it keeps your code together. So there's many ways to skin that cat.
Yep. Okay, don't have anything to add to that one. Next one is from Shravan. Within 30 seconds or 15 minutes, is it allowed to serve multiple requests, or does it spin up a few new function instances per request? Is the time to live configurable? So this would be for any given.
The time to live to configurable that's the maximum amount of time you're allowed. So for example, if you've got an SQS process, you know it should never take you more than a minute, but you don't want to wait for the 15-minute mark just in case something has gone into an infinite loop and you don't want to be charged for the 14 minutes that you know it should never have done. Set it to 14 minutes, right? So if another event comes in while that one's still processing, of course it's going to spin up another effectively container to process that. To you, it makes no difference to the cost. You're still charged on a per cost basis, whether it's serially or in parallel. It all comes down to the generation of those events. Where are those events coming from?
Yeah, I think that's the key point there, is effectively it scales out once you get into multiple parallel requests. So as long as that one that's already been kind of spun up isn't being actively used and it hasn't timed out, and if you're referring to that timeout, that isn't configurable. You can't tell it basically how long to keep a previously alive instance alive. That's kind of a black magic that AWS doesn't really give you a whole lot of information on. But effectively, the only time it's going to spawn another one is either there's none currently alive, or the one that's currently alive, or all of them that are currently alive, are actively handling a request. At that point, they're going to bring up another one in parallel, and then it'll sort of kind of scale them back down as they basically go cold, hence going back to a cold start. Next one is from Han. What if they decide to change, aka really increase the pricing? Can you go bankrupt? I'll mention this one. I don't think, and I may be wrong here, but I don't think I've ever seen AWS increase prices. They launch new services and they launch new things, but historically they're always lowering prices on pre-existing services. And that's just partly due to competition. while we've been talking a lot about AWS, there are other horses in this race, such as Azure. They have a lot of similar capabilities, and so there is usually a pricing war. So we've seen that recently kind of with the Cloudflare stuff, where Cloudflare has brought out some cheaper storage pricing, and we're expecting pricing for S3 to start going down here in the next couple of months to years as they have to compete with that. So the pricing aspect, as long as you can swallow the cost today, and like I said, you don't have a balloon, I wouldn't necessarily worry about all of a sudden AWS coming back and saying, oh, we used to charge you $350, now we're going to charge you $7. I just don't see that.
But again, you can architect your code in such a way that, because again, these are just interfaces, it's plain old Java objects, you should be able to move that business logic, which is really your core IPR, not the fluff around it. Your core IPR is that function. That should be able to, you could live that in another container somewhere else, you know. So for example, in the node world, where sometimes you've got a lot of requests coming in, you know, there will be a metric at some point where you're thinking, okay, this API is getting hit so hard, so often, it's probably cheaper for me to spin up my own small bank of node servers. I mean, there's no JavaScript code to be changed for that particular environment there. It's a simple run up a node library here. And Java's the same thing. We've got so many tools available to us to host that function. We run up our own JVMs if we need to. So you're not shoehorned into that world.
And this actually bumps into it perfectly. So the next question is from Nathan. How to avoid vendor lock?
The only bit is, again, you can do that, and there's certain libraries to effectively abstract out. You've seen the two AWS functions that are coming in. Again, we can abstract that out one layer above in sort of like a factory method, so you don't have to worry about it. So your same code can deploy on Azure as it could do on AWS. I have seen that.
So the next one isn't so much a question, but our good friend Kirk was in the comments as well. He just wanted to mention that server startup is a vanity metric. If you measure OS machine time, crush, process, and startup time budget. So,
and this is why I love you, Kirk. I love you to bits. I remember having a wonderful debate with you about saying people should be okay with CPUs running at 100%. You've got the CPU, use it. Don't see 100% CPU as a bad thing. No, it's a wonderful thing. So Kirk, thank you.
The next one's from Brad. AWS Lambda is excellent, but why use Java? Other languages run nearly instantaneously. Obviously referring to startup times.
I think we've answered that one, yeah. But
yep. Yeah, I understand. Yep. Another one from Nathan. Can you suggest ways of handling the cold start, like retrieves, etc.? So what are some common principles to effectively avoid the cold start demon?
There's really not much you can do, but just by trying to keep things small and light in that respect. And also just keep triggering it. It's okay to, like, you've seen the cost of a single request. Eat it. One extra call every 5 minutes is not going to pop on your CFO report when you're putting in the expenses for your AWS cloud bill.
Yeah. And I think that also circles back to one of the comments we made earlier, which is don't go for 100 small functions. Like, that's also where if you start bundling your functions into certain commonality, you can start avoiding the cold start to a certain extent, because one of those functions is more than likely going to be getting hit. So if you're just trying to serve this one that doesn't get very often, yes, it's probably going to be cold all the time. But if it's kind of sitting alongside another endpoint that is getting hit more frequently, then you kind of avoid the cold start just by the nature of that one always getting called. So that's where, again, kind of finding that right balance of kind of bundling light functions together can help you avoid some cold starts with the less commonly executed ones. Let's see. Next one is from Ram. Is there a way to prevent my Lambda from going cold? Also, will I be charged if my Lambda never gets cold and always stay in the execution state? So we just talked about from going cold. No, like I said, the only really way to stop it is to call it. There's nothing else to prevent that. And yes, if your Lambda is staying in the execution state, and I'm going to say here the execution state is it's actually processing, so you're running actually billable time, then yes, you are getting charged the entire time it's executing. Now the caveat to there is when it's in that kind of like pause state, that kind of, I always refer to it more as like the zombie state. It's still alive, but nobody's talking to it and it's kind of sitting off to the side. You're not getting charged for that. So as long as it's in that kind of lukewarm zombie state, you don't pay for that billing and it'll come back alive very quickly.
And that's why we've got the maximum time on it. So it can't go more than, say, 15 minutes or 30 seconds, depending on what it's answering.
All right, this is a good one. This one's from Vishnu. Please comment on debugging a Lambda if a problem happens in production.
Oh, it's a great question. It's hard. You can't put a stack trace on it. You got to run it locally in order to figure it out. And again, and I refer back to our old friend Kirk, who said, logging is not expensive. I mean, if you've got to a situation of where logging is now starting to slow down your thing, then you're in the wrong business. So if that's the case, then redeploy your Lambda with a lot richer logging to figure out where it is again. But again, we go back to our testing stuff. You should be able to test this stuff very, very easily and quickly because it's a much smaller execution space, effectively. I mean, you're not trying to, which thread could be accidentally touching this one that this one is now knocked off. You don't get the same sort of problems as you would in an app server as you would here because there's not that.
It's really hard to.
You're not sharing a JVM with another process.
Because generally your functions are executing so short, unless you're like in an infinite loop sort of situation or a recursion thing, you generally don't blow your heap out with one of these guys because you're not running long enough to do it.
And you're not sharing it with anybody else. I mean, that's so in an app server, you're at the mercy of somebody else that's running in that world. Another thread that another request is thrown off. You're not in that world in this environment.
I think the one thing though is since you don't get as much insight in terms of like the JVM and what's kind of going on there, it does highlight the need to be very efficient with your logging. So making sure you have a good amount of logs in your logs so that you can kind of tell where you're at in execution. Then obviously making sure you're out, if you catch an error, you're logging the stack trace so that it helps when you are coming behind to know where it blew up. And then ideally, you're also kind of to a certain extent know what data was coming in at the top of the function, so that way you can kind of go back to your local machine and recreate it. Because once you know enough information where you can recreate it locally, debugging it just becomes a trivial matter of rerunning it and simulating it effectively. Right, so that's all the ones I wrote down. Let me just do a quick scan of the comments since we've been talking. Oh, this is a good one. Have you ever been surprised about the AWS bill? I'll answer this one. No. And the reason why I'm going to say no is hopefully your DevOps person has put billing alerts in place to effectively know whether or not you are exceeding what you expect to spend. If you are running an AWS account with no billing alerts in, please go change that now, because that is where you do hear the horror stories of, oh my God, I got a $20,000 bill, whether that's just because I left something running or somebody took over my account. So we always have effectively alerts in place that has basically what we know what we should be generating in terms of output, and we'll tune that as our spend increases. But we get the alert very quickly in terms of, okay, we've just hit our monthly budget and we're on week 2. Something's going wrong, and then we go in and start diving into that. And also, depending on what the situation is, AWS historically, and I'm sure the other cloud providers again are as well, they tend to give you one mulligan in terms of if you've done an honest mistake or somebody's compromised your account and done something to really run up a bill, you can often talk to support and they'll give you a bit of a mulligan. But obviously, if you keep doing that,
so that intern that got excited with that big EC2 instance that they run up. Okay, and again, we generally deploy our productions in a separate Amazon account. So you can, so such intern noise gets excluded away from that. But no, we've never been surprised by a bill.
All right, let me see if there's any other ones. Bill has asked for your GitHub repo and any books you would recommend.
Yes, and I'll put all that in the chat for the YouTube link. I'll get that updated for that.
Okay, and let's see, public cloud.
I think we've overrun here quite a bit, right?
Yeah, and that's all. Pretty much all the ones I'm seeing. Sorry, hang on. Can we use jars in Fargate like in Lambda, or does it have to be a Docker container? That's more for me, I would say. So ECS and Fargate are Docker containers, so that's effectively what you're running, are Docker containers. So it's going to be a Docker container, but you can usually leverage some form of pre-built one. I mean, there's plenty of JVM ones out there that makes it very easy. And again, that's a well-trodden path. But yes, in Fargate, you still would be, it's Docker, but your jars is going into the Docker. All right. Well, that's everything, everybody. Thank you for joining us. Alan, thank you for the wonderful talk.
Thank you. Appreciate it.
All right. Everybody have a good day.